All right, continuing on with our Chapter 6 videos, and we're on question number 4. So we want to balance this equation. Now I'm going to give you a hint, a helpful tip. So when you have polyatomic ions that stay the same on both sides, you can balance the polyatomic as a whole unit, just as you would an individual element. So let's take a look at what we have. So we have NH4 on the left. And if we look on the right, look, we have NH4. CO3, let's look for that one. CO3 as a unit, and then over here on the right, we have CO3 as a unit. NO3 as a unit, and NO3 as a unit. So I can balance each of those polyatomics the same way that I would balance an individual element. So now that I know that, I'm going to approach this problem exactly the same way. So I'm going to make my list. So on the left, I have NH4, I have 2 of them. I have CO3, and I have 1 of them. I have barium, and I have 1 of them. And then my NO3, it's in parentheses with a 2 behind it, so that means that I have 2 of them. Right now on the right, I'm going to do the same thing. I have NH4, and there's 1 of those. CO3 is there, and I have 1 of those. Barium, I have 1, and NO3, I have 1. So the only thing that's not balanced are the NH4 and the NO3. So on the left, I have 2 NH4s. On the right, I have 1. So if I put a 2 in front of that compound, that means that I now have 2 NH4s and 2 NO3s. And that balances everything out. So if I write those coefficients with commas, just 1 for each thing, I have 1 NH42CO3. I have 1 barium nitrate. I have 2 ammonium nitrates, NH4NO3, and I have 1 barium carbonate. Here. All right, so we're going to balance this equation just like we have in the previous ones. So I'm going to start by making my lists. So on the left, I have 1 iridium. I have 5 fluorines. And I have 2 hydrogens. On the right, I have 1 iridium. I have 5 fluorines, because there's 4 here and 1 more there. And I have 1 hydrogen. Okay, so we're going to use a little bit of a trick here, and you'll see how it works out in just a second. So everything's balanced except for my hydrogens. I've got 2 on the right, 1 on the left. I can't change that. Okay, but what I can do is I can put a coefficient of 1/2 just for now. Okay, so if I do that, then that cuts my hydrogen in half, and I have 1. The problem is that I'm not allowed to do fractions. No fractions in the final answer. Okay, whole numbers only. Right, so how do I get rid of the fraction? I'm going to multiply the entire thing by 2. Okay, so if I take and multiply the entire equation by 2, 2 times 1/2 is 1, right? So that eliminates my fraction. So let's multiply everything by 2. So if I have a 2 And then right here with the hydrogen, I'll have 2 times 1/2. That makes a 1, a 2, and a 2. All right, so let's take a look at how our balancing looks. All right, so if I do it that way, now I have 2 iridiums, I have 10 fluorines, and I have 2 hydrogens. Oh, excuse me, 4 hydrogens. No, 2 hydrogens. Sorry. And then on the right, I have 2 iridiums. I have 2 times 4 fluorines plus 2 more fluorines with the HF makes 10 fluorines and 2 hydrogens. Okay, so our coefficients with commas will read 2, 1, 2, and 2. Okay, so using the fraction method helps to get around the fact that we have a diatomic, that H2. Okay? Tricky little one. All right, so which equation best describes this reaction? So let's see what we have here. I've got 1, 2, 3 N2s. It looks like 1, 2, 3, 4, 5, 6, 7, 8, 9 H2s. And then on the right, looks like I have 1, 2, 3, 4, 5, 6 NH3s. Okay, but I want to make sure everything is in the lowest possible multiples of itself. So I'm going to divide everything by 3. So I have N2, 3H2, and 2 NH3, which is our bottom equation. Number 7, which best describes this reaction? So let's take a look. Let's see, like I've got 1, 2, 3, 4 borons, and 1, 2, 3, 4, 5, 6 Cl2s. And then on the right, looks like I have 1, 2, 3, 4 barium chlorides, or boron trichlorides, excuse me. All right, so again, I have common multiples. So if I divide everything by 2, I get a 2 boron, a 3 Cl2, and a 2 BCl3. All right, looks like our third answer right here. Okay, I'm going to go ahead and pause this video right here, and we'll pick it up on our next video talking about different categories of reactions.